Forward. Okay, great. Thank you very much. Well, it's a great set of talks already, and I'm sure the discussion this afternoon is going to be wonderful. I do work now at the HDF Group, which is involved in standard formats and now standard documentation for data sets, but I did spend quite a few years at a NOAA data center, so I'm sort of used to looking at data. And of course, when you discover data and you get it down on your computer, and I agree that a lot of people use Excel. In fact, I used it for making this plot, and you see that this is a global parameter, and there's this 50% change that happens in about 1 month in 2007, and the question is why. So we spend a lot of time talking about metadata, and we spend a lot of time talking about discovery and discovery of data, but what we really need is metadata that helps us understand why is the data that we get doing it. So Dave brought this point up before, and it's really important, is that I try and avoid using the metadata word because many scientists don't really like metadata, but they all sort of grudgingly agree that documentation is important. So one thing that we might want to think about is talking about documentation, and it's definitely not discovery. The three uses for metadata that I talk about are discovery, use, which allows you to get the data into your tools, but then the really critical one is understanding. Being able to understand the data once you get it and you see something funny, you need to be able to understand it. The fourth one, I think, is trust, and that's really the most important. So I agree completely with what Joel said about institutions being important, and I wanted to talk just a little bit about the model of adoption, sort of the disruptive innovation model. We have a disruption that happens, and after that happens, there's an era of ferment. There's high risk, there's a lot of uncertainty, there's considerable waste, and there's no interoperability. And I would argue that we're in an era of ferment now, and we all deal with a number of disruptions. So maybe the big data one, maybe the emergence of new, in my geoscience field at least, international standards. But then over time, so all of us are these little lines that are on this diagram, and we're trying to figure out how we should do things. What happens is there's a selection process, and then the community grows because the energy is focused. The rate of progress increases, the community focuses, and developments are supportive and cumulative. And I hope that we're getting close to a selection and a transition from this era of ferment into an era where our communities are actually helping each other and accumulating and supporting their efforts. I've been thinking during Joel's talk, one of the really important things I think we need to think about is acting into a new way of thinking, rather than thinking into a new way of acting. I would suggest that we spend a lot of time thinking and hoping that that changes the way we act, but I think it's also important to change the way that we act, and then through that change the way that we think. So some people, you all have heard of the tipping point or the turning point, and what does that look like? I'm going to show you just covers of things. This is the World Meteorological Organization. This is the Next Gen project. This is NOAA and NASA GOES-R. This is the U.S. Geologic or Geosciences Information Network. This is NASA Earth Science. This is an international standards body. This is the Federal Coordinator for Meteorology and Metadata, NSF, the data management requirements, the Federal Geographic Data Committee endorsing standards that they didn't develop, the Group for High Resolution SST, INSPIRE, the EU metadata and data sharing initiative that I'm sure you're all familiar with, the Australia and New Zealand metadata profile, and then finally the AMS, the American Meteorological Society metadata policy. All of these groups have agreed to adopt the same international standards for documenting scientific data sets, earth sciences, that they're changing. So this is evidence, I would say, that we've gotten past, in a number of cases at least, this era of ferment, and a lot of the major players. It was interesting in Joel's talk that NOAA and NASA were the number one and number two sources of data. Those groups have already decided that they're using these international standards for documenting their data. This recommendation from the AMS was really important because it talks about coordination with other organizations within the community and providing education and on the nomenclature, the structure, and implementation of metadata. So this is very much in line with what Rebecca was talking about and Fran was talking about in terms of really educating the community. And that's part of acting into a new way of thinking, right? They come into a workshop, they learn how to act, and through that action, they learn how to think more like they should be working together. So one of the ideas that I sort of messed around with for a while was the idea of a consortium. A consortium is an association of two or more organizations that participate in a common activity to achieve a common goal. And in this case, our goal is really to enhance the exchange and understanding and use or reuse of Earth systems data across disciplinary and international boundaries. And I would say that in this group, obviously we're not limited to Earth systems data. It's sort of an older slide, but we want to be integrating all these different kinds of data sets. And the real question is, could the organizations, the federal agencies, actually form a consortium and in that consortium work on standards, training, and tool adoption and development together? Because as we come through this disruption and we go from the era of ferment into having a selection and making progress, we need to work together, and not only on standards, but guidance about how those standards are used. That's the education and outreach piece. Training, here's how you do these things, and then tools, we take existing tools, we adopt them, and maybe we develop some new tools. So I would challenge the federal infrastructure, which I was a part of for quite a while, to try and come together and start acting rather than thinking about acting. What does this look like? We talk a lot about metadata tools, and a lot of the picture that we look at looks like this. It looks like a portal. We've seen a few slides with portals today, and this is it's sort of the sexy data discovery thing. Okay, it's usually what gets funded, and you know, who knows? Of course, I guess someone who invented the word portal thought there was only going to be one of them. Now it's sort of hard to tell portals from web pages. There's so many of them. But in the metadata piece, a lot of times these sit on web accessible folders. These could be caches of metadata that come out of database, but they're held in the current state of them is in folders. And this is sort of how far we get in terms of the tools. At NOAA, I worked quite a bit focused more on tools, not for the end users of metadata, but for the creators of metadata. And I think that's really an important thing that we need to do. We use something called Rubrics, which I'll show in a second, for evaluating the completeness of metadata. We use different views of the metadata to share the information with users and with providers in different ways. And we worked quite a bit on connections between standards. I agree completely with what Fran said about harmonized standards. I also agree with what Ari said earlier, that if we get the common pile done, then these connections can be done as extensions to that common pile. I think that's really important, having a good extension model. The other thing that we did at NOAA is we created a wiki, which has over 250 pages about the ISO standards, the international standards for geographic data that we're working on. And the wiki is really the community knowledge base. It's very, very important to have the wiki be a place where people can share lessons learned and share examples, and something that can serve as an authoritative a source, but maybe not. You know, I like very much like what Gerhard's saying. These things all evolve. So in the terms of the wiki, you sort of get your best estimate down there at any given time, and the community helps you evolve it. It's very important to support that evolution. And particularly as we're learning and then extending our learning across different disciplines. So the systems that we built connect all of these things together. We have web accessible folders that have rubrics that are used for evaluating things. We have different views of the metadata, and all of those things point back to pages in the wiki. So this is sort of the evolution from a desktop system where you have help that people use on the desktop to a community support environment in which the wiki and the community provide the support and the sort of help pages and et cetera, but the whole integrated system is really aimed at improving documentation. So this is what the rubrics look like. I'm sort of, in terms of Mark's talk, I'm sort of in the complex big UML model thing because I do international standards. It's not quite as complex as the one he showed. Of course, mine is simpler. But we break it up into spirals, just like we do when we're doing software development. We break the big piece up into smaller pieces, and these spirals have a collection of fields in the metadata, and their goals, and then progress of each of those is measured automatically using, in this case, an XSL. And every record has a score that can be calculated using a consistent standard tool. And of course, different communities, you can have one tool that goes across a lot of communities, or different communities can build their own because it's using a standard kind of approach. And with time, these scores go up. The one question about how do you motivate people to improve their stuff, one of the 5 questions. We come from a community that has a lot of people in it that are used to getting grades. And if you want them to do better at something, you create a mechanism for grading them, and they will do better on their own. That's my model, and I'm sticking to it. The rubric's been very useful that way, but it breaks up the goals of what you're trying to achieve from this big thing that looks like this very complicated thing into small pieces that you can get done in a couple of days or maybe a day, and it also really importantly lays out the path of improvement that you're going to go along in the future. So you can say, today I'm working on identification, tomorrow I'm working on connections, and having that improvement path, I think, is super helpful. Finally, we've done a lot of talking today about users, and I think it's important, and actually some of the people here are in this picture. I think it's important, these are the users that a lot of us think about. We're trying to figure out what they're trying to do, but in fact, these are really our users. And it's nice to see Reagan Moore here, because at one time he said, why should we be doing this data preservation stuff? And maybe he remembers, he said data preservation is communicating with the future. And I think that's really important, that the things that we create today, the well-documented data sets today, will be used in the future. The users that we have today that we're trying to help build these systems are one part of the use community, but they're really only a small part.